Good morning, everyone. Thank you for joining us and welcome back. Glad that you're here. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, the Science and Technology channel.
Yeah, and we hope you are having as great a weather as we are here in Southern California. It is beautiful. Not good for the water, not good for the snow and the people that rely on snow for their income, but we are having just beautiful weather. I think it was 74 degrees here yesterday in February, and that is just unusual.
That just means it's going to get hotter sooner.
Or colder, or we're going to get slammed and March and April. But yep, so we're talking about a good one today. Another space topic. So
Very
here we
interesting.
Go. Yeah.
Astronomers at the International Center for Radio Astronomy Research, working with international collaborators, have made a striking discovery involving a previously unknown type of cosmic phenomena. A strange astronomical object known as ASKAP, ASKAP J1832-0911. We're just going to call it ASCAP now. And it's in the Scutum constellation, Scutum. Never heard of that constellation. Have you, Scott?
No, I have not.
I don't know if it's Southern Hemisphere. Probably Southern. It's not Northern Hemisphere. Produces bursts of radio waves and X-rays that last about 2 minutes and repeat every 44 minutes.
Wow.
I wonder what would do that on regular intervals.
Yeah.
This regular pattern places it in a rare class of sources called long period transients, or LPTs. Would you like to know more?
What makes this discovery especially notable is that it marks the first time an LPT has been observed emitting X-rays. Astronomers believe this new evidence could help explain the origin of other puzzling signals that have been detected across the sky but remain poorly understood.
The research team identified ASCAP using the Australian Square Kilometre Array Pathfinder radio telescope on Wajari County in Australia. So it is Southern Hemisphere, which is operated by CICRO. That's an acronym, CSIRO. They then matched those radio pulses with X-ray flashes recording by Chandra X-ray Observatory, which happened to be observing the same region of the sky at the same time. What a coincidence.
Yeah. Long-term transients are a relatively new category of cosmic source defined by radio pulses separated by minutes or even hours. Since, what do we call this?
That's observatory, ICRAR?
ICRAR. Researchers first identified this type of object in 2022, so not too long ago. Astronomers worldwide have found 10 examples so far. Interesting.
This is strange.
Yeah.
Despite these discoveries, scientists still do not know what produces LPTs or why their signals turn on and off at such long, regular, and unusual intervals. The detection of X-rays from ASCAP now provides a crucial new clue that may help narrow down the physical processes behind these enigmatic cosmic signals.
ASCAP, this is a quote, ASCAP could be a magnetar, which is the core of a dead star with powerful magnetic fields. Interesting. Or it could be a pair of stars in a binary system where one of the two is a highly magnetized white dwarf, which would be a low-mass star at the end of its evolution. However, even those theories do not fully explain what we're observing. This discovery could indicate a new type of physics or new models of stellar evolution, end quote. Or it could be the Death Star emitting far, far, far away from a long time ago. Little Star Wars reference there, huh?
A little humor there.
Yeah.
Detecting these objects using both X-rays and radio waves may help astronomers find more examples and learn more about them, according to second author Professor Nanda Ria from the Institute of Space Science, ICE, and Catalan, I don't know if I'm pronouncing that right, that's in Spain, Institute for Space Studies in Spain. Quote, finding one such object hints at the existence of many more. The discovery of its transient X-ray emissions opens fresh insights into their mysterious nature, she says.
The discovery also helps narrow down what the objects might be. Since X-rays are much higher energy than radio waves, Any theory must account for both types of emission. A valuable clue, given their nature, remains a cosmic mystery. ASKAP J1832-0911 is located in our Milky Way galaxy, about 15,000 light years from Earth. So not that far as light years go, right?
Right, really close. And again,
Yeah.
it's in the Scutum constellation. And I should have had this picture up the whole time, but for some reason, I didn't have it up. So here it is. There you go.
Yeah, that's a good one. One thing just came to my mind, and I know this is a deep thought for me anyway, but we have been talking about space now for a long time, going into our third year, right?
Yeah.
And I didn't realize that there were so many agencies and institutes and organizations that are studying this stuff. I just figured, it's like NASA, Caltech, maybe a few around the world, but there are dozens. We talk about dozens all the time. This is crazy. Interesting.
Yeah, it's really cool. And besides all the professional people in the institutes, there's a lot of amateur astronomers out there that they actually find stuff.
Yeah, grab yourself a telescope or make a telescope, and you're out there, and wow, you come across something. So that's pretty cool.
It's really cool.
Yeah.
All right, folks. Thanks for joining us. We'll catch you tomorrow or this afternoon.
All right. Yeah, catch you this afternoon. Thanks. Take care.